Good afternoon, everyone. My name is Jiayi Liao from University of Science and Technology of China. Welcome to my talk about large language recommendation assistant. Sequential recommendation is to predict the next item the user might interact with based on user interaction history. As we all know, large language models with textual input and output exhibit extensive raw knowledge and innate reasoning capabilities. To explore the potential of large language models in sequential recommendation, here comes a question on how to reshape sequential recommendation as the language modeling task. In other words, we need to convert the behavioral sequence into the textual input prompt. Something like this user has watched item 1, item 2, item n. Please predict the next movie this user will watch. When it comes to representing items in the prompt like item K, we've seen a few different approaches in previous studies. First up, some studies use an ID number to represent each item, like 2024, for example. But the thing is, LLM tokenizer might split these numbers into several tokens. Another approach is to use a randomly initialized ID token for each item, but this can lead to a whole bunch of out-of-vocabulary tokens, which isn't ideal. Plus, both of these two methods don't really take into account the textual features of the items. Lastly, there's the opinion to represent each item using textual metadata, like the movie title, Titanic. The downside is that the recommendation process only focuses on the semantic connections between items. So, drawing inspiration from multimodal language models that adaptively understand and reason across diverse modalities, we propose viewing the sequential behaviors of users as a new modality for LLMs in recommendation and aligning it with the language space. And to this end, we propose a novel framework named Large Language Recommendation Assistant, or LLaRA for short. Beyond the text-only prompting, we exploit hybrid prompting to align the behavior representations as derived from recommendation systems with language space of LLMs, first focusing on the text-only prompting, then progressively transitioning to hybrid prompting. And now let's dive into the details of how it works. First off, let's talk about how we represent items. Textual features of items like titles and descriptions are crucial if we want to tap into the common sense knowledge that LLMs naturally have. For each item, we use the LLM tokenizer and word embedding layer to get its textual tokens from the text metadata. Such textual token representations are inherently compatible with LLMs. In parallel, conventional sequential recommender models such as Jiayi for RAG, SIGIR, and SUSRAG effectively capture sequential patterns with ID-based item embeddings after training. But unlike item-aware tasks that can be easily slotted into the prompt and understood by LLMs, the ID-based item representations might be incompatible with the text nature of LLM prompts. To bridge the modality gap between the ID-based representation space of recommenders and the language space of LLMs, we introduce a specialized module, SR to LLM. This module uses a trainable projector to project the ID-based item embedding into the LLM space, giving us the behavior token representation. Once we have these two, the textual tokens and the behavioral token for an item, we integrate these two components to create a more comprehensive descriptions of the item. Next, we need to design the prompt for LLMs, which should include a few key elements. First, a clear description of the sequential recommendation task, for example, predicting the next movie this user will watch. The second is the sequence of historical user item interactions. And the third is the set of candidate items from which the LLM is to generate responses to the given task. We initially adopt a straightforward method, text-only prompting, representing items while textual metadata within the prompts. Within the input prompts, each item is represented using the textual tokens followed by a placeholder token. To incorporate behavior insights captured by recommender models into the prompts, we have designed another prompting method, hybrid prompting. All the items in the prompts are represented in a hybrid manner. That means all the placeholder tokens in the text-only prompts are replaced by the behavior tokens. While the text-only prompting aligns closely with LLM's training and is thus more readily assimilated, the hybrid prompting deviating from typical language data introduces a more complex task. So we define them as an easy and hard learning task separately. Inspired by the curriculum learning, we design a curriculum prompt tuning scheme, tuning from easier to harder. The tuning process begins by text-only prompting method, allowing the model to establish a fundamental grasp of the sequential recommendations task. Guided by the scheduler, we gradually introduce the hybrid prompting method that incorporates behavioral token, thereby elevating the complexity of the tuning process. This stepwise strategy ensures that the model is not overwhelmed by the complex tasks. Ultimately, our LLM-based recommender will be fully integrated with the hybrid item representation. In our experiments, we are going to demonstrate how effective of our framework is by answering 3 key research questions. The first research question is, how does LLaRA perform compared with traditional sequential recommender models and LLM-based methods? And the second is, how does our hybrid prompting perform in comparison to other forms of item representation in prompt design? The third is, how does our curriculum learning scheme measure against other modality injection methods? For research question 1, we compare LLaRA with traditional sequential recommender models like Jiayi, SIGIR, and SUSREC, and LLM-based methods like Llama 2, GPT-4, MORAC, and TORAC. We can see that LLaRA outperforms all the baselines on all 3 datasets on the metric of hit ratio at 1. And this validates its effective integration of traditional sequential information with the extensive raw knowledge and robust reasoning capabilities of large language models. For the second research question, we compare the hybrid item representation with a numerical index, behavioral token, and textual feature. We can observe that the performance of LLaRA's items representation surpasses other methods. This not only corroborates the effectiveness of our item representation method, but also illustrates the insufficiency of solely relying on semantic information or sequential information. For the third research question, curriculum learning employed by LLaRA consistently outperforms the two baselines, which is directly training with hybrid prompting and two-stage training. LLaRA starts from the easy task and progressively change to the hard task, utilizing a sampler to schedule the training process. The improvement brought by this gradual learning method underscores the effectiveness of our curriculum prompt tuning scheme. In addition, we select two typical cases and the answers generated by three models, SIGIR, TORAC, and LLaRA. The user on the left prefers adventure and war dreams according to the viewing history. With the world knowledge about these movies, TORAC and LLaRA correctly recommend the Great Escape movie. For the user on the right, SIGIR and LLaRA recommend Batman and Robin according to the sequential behavior patterns of users, which is the correct next items the user watch. In the end, we summarize two take-home messages. We introduce a novel framework incorporating both semantic information and behavior knowledge for item representation in large language model-based sequential recommenders. This work marks an initial step in transitioning from the traditional recommender models to a more sophisticated approach underpinned by LLMs and opens up new research probabilities. That's all. Thanks for your listening.